All right, good morning and welcome to this week's edition of Boundaries Webinar Wednesdays. My name is Shei Shambore and I will be guiding you through today's webinar. Now, just to confirm that that all the attendees and everyone are hearing me loud and clear and you're able to see my screen as well. On the right-hand side of your screen, there should be a GoToWebinar control panel. It should be gray. You may have to click on a tiny red arrow to pull it out if it's collapsed. But if it's in there, can you click on the raise your hand button just so that way you can confirm that you can see my screen and you can hear me and you can everything is coming in loud and clear, just so that way I know that I haven't fat fingered a button here from my end. All right, I see a few hands being raised. That's wonderful. Thanks. Yep, that lets me know that you can hear me and see me okay. Okay, wonderful. So we'll go ahead and get started. So as I said before, my name is Shei Shambore, and I will be guiding you through today's webinar on embedding design requirements in Creo, and the functionality that's used to do that is behavioral modeling. All right, so we'll go ahead and get started. The other quick thing by way of introduction as well is that currently on GoToWebinar, everyone is muted. All the attendees are muted. So if you have a question, you can type it in the questions panel of the GoToWebinar control panel that I just talked about. And when you type in those questions, they'll come in here, and our team will be able to answer them either live right now, or we'll follow up with whoever asked the question by email afterwards as well. All right. So we'll start off, and so the way today is going to go is we're going to have a very quick introduction to boundary systems and who we are, and then we're going to talk about specifying design requirements or targets and how you can take a look at that inside of behavioral modeling. We'll describe what behavioral modeling is in Creo and what you can use it for. And then we'll go through a live demonstration of the software, how you would use it. And finally, we'll come back and talk about, why does it matter that, you can do these kinds of things in behavioral modeling. So we'll take a look at that, and then we'll finally get into some questions and answers at the end. All right, so a very quick introduction about Boundary Systems and who we are. We are a product development consulting company based out of Cleveland, Ohio. But really, we have a nationwide and even an international reach, and we help companies that do product development, design products smarter, better, and faster, and we do that using a suite of software tools that we partner with, and we are experts in those softwares, and our capabilities span everything from PLM to CAD data management. We also do a lot of design and consulting, and also a lot of simulation as well. And this particular topic falls right within the CAD design and consulting and the product development route, and it could also be some simulation as well, depending on how it's used, right? All right, so to get off, we'll get started here. And before I actually, dive into talking about behavioral modeling in a second, I'll actually, do a quick detour on design requirements or design objectives and targets, and what that entails. And technically, usually you'll have a case where in your design you'll have certain targets that you're expected to hit, and it could be either due to the form and function of the model, or it could be due to other specifications or other calculations that have been run. It could be due to a variety of different factors. So for example, over here in this model, you'll have certain, overall dimensions for the size of that fuel tank that you can see up there in your picture. You'll have certain overall, maybe length, width and height dimensions of a general envelope that it should be able to fit in, right? And then you'd also have certain areas around the fuel tank that you cannot have fuel tank material because maybe there's some other components in there. Maybe you have the fuel sensor there. Maybe you have a few other components around it where you have to make space for, right? So you just can't use the entire volume, length, height, and width for it. You have to make all these small adjustments to that volume in order to accommodate the other components, right? So you'll have certain dimensions that are non-negotiables, right? But then you also have certain dimensions that are negotiable, right? But the critical target, for example, a design requirement in the case of a fuel tank for a car would be, I don't know, maybe the fuel capacity should be, I don't know, 17 gallons or 18 gallons or however big the fuel tank is being designed for, right? And so you'll know you have a certain target, fluid level that you want, whenever it's filled up to, the fuel to be at, and for that fluid level, you'd want that volume to be a certain amount, right? And so then that becomes your design target, right? And in other cases, it could be, mass calculations, it could be center of gravity calculations, it could be cost calculations as well. But your design targets can vary depending on what your application or your design is. But again, it's a matter of, finding out what your negotiable design variables are, right? What are some of the 2, 3, 4 different dimensions or parameters you can tweak inside of Creo Parametric? And what's the optimal Goldilocks combination of those dimensions to where when you tweak them just enough, you're in your sweet spot where you hit your design target, right? And really that's what behavioral modeling helps you with, right? And so now we'll talk in here, about behavioral modeling, and really it's a way of embedding either fit, form, or function, or all three, into a Creo model, right? And the way you would do that is, you specify a design target, and then you give Creo a range of values within which it can play with, and Creo will then, conduct iterative, trial or error, analyses in order to find the optimal solution for you, right? So Creo then automatically changes dimensions, calculates the end result, and finds you and reports that back to you in such a way where you can then make some, engineering decisions on, what the final, design should look like, and in a way where it meets your design targets. All right, so in Creo, the typical behavioral modeling process typically starts off where you create your design model. So in this case, you create sort of the base for that fuel tank over there, and then you do some sort of analysis on the design model, right? And so that's step 2, and step 2 is you can think of analysis, in a broader term. What Creo is technically asking for in that case is essentially, tell me what the goal or the objective is. Tell me what you want to measure. Tell me what the ultimate criteria by which you're measuring success is going to be, right? So in the case of this fuel tank, for example, you're going to do an analysis that, tells Creo, within that fuel tank, from the fluid level down below, it should calculate the volume of that space, right? And that is going to be, the analysis you're going to do, right? And so in that case, then, in steps 3 and 4, you can then tell Creo to analyze that volume and make sure that it's, equal to or greater than a certain number. In this case, 17 gallons, for example. Right, and so really, step 2 is just a way of telling Creo your goal or your objective, or what your criteria is that determines success in terms of what it is you want to get out of the system, right? And the critical thing is at step 2, again, analyzing the design model. It could be, any kind of analysis you can do on it. So really just, a snapshot of some of the different kinds of analyses that you can do within behavioral modeling in Creo could be, measurement features, right? And so it could be measuring a certain distance, or measuring a certain volume or area, and setting that in Creo as a target, so that way you could then optimize to that area or volume to a specific value. It could be mass property features, or where you're looking at either the mass or the center of gravity or the moment of inertia or things like that. It could be some analysis features as well. So for example, some of those analysis features would be either Creo relations that you could calculate, or Excel calculations, or even MathCAD calculations as well. And so there's a lot of ways you can specify for Creo what it is your design objective or target is, right? And that's really what's involved in the analysis of the design model, right? And then the next step, which is optional, but again, it's something you can do, and it can give you a lot of visibility into your model, is doing a sensitivity analysis, right? And really, that's just a case where you're given Creo a certain dimension, right? A certain variable that is negotiable in your system, right? And you're having Creo change that volume, right? Or I guess change that dimension, and then plot a graph that shows you how that dimension changes against your design objective or your analysis feature that you just defined prior to this, right? And so in this example here of this chart, Creo is showing you here, if you take a certain dimension in that fuel tank and you change it between, I don't know, about 73 or 74 and 92 or so, it shows you how the volume increases from about, I don't know, that's probably about 280,000. I believe that's about millimeters squared or so or whatever the units for that graph is, increases all the way up to about 325, right, thousand. And so again, that shows you then, what the variation is. And this sensitivity analysis is good for a couple of things. One is it shows you, what design variables have a positive or a negative impact on your design objective. So you can see the slope of the graph in that way. You can see which design variables have zero impact on your design objective, right? So which ones do you change, from start to finish, and the resulting sensitivity plot looks like a flat line, right? To where there's zero impact, and then you don't need to bother about changing those, right? And it'll also show you in a case where, for example, there's a nonlinear relationship between your design objectives and your variables. So in other words, if there's a parabolic relationship between them, to where it either starts low and then goes high and then comes back low, right? And so then the sweet spot is going to be somewhere in the middle rather than just going from zero to high, right? And so you can start to tell the relationship between your design inputs and your objectives, using these sensitivity plots that Creo generates for you, right? And the other thing about this is, again, it's also a time-saving feature, because you're essentially specifying for Creo the upper and lower bounds for that dimension for it to change, and you're telling it how many times to change it, right? And then you could, leave Creo running, and you could, go do some other high-value tasks, and Creo will then automatically regenerate the model, right? And then, perform the analysis and report the result for you in that graph, right? And it doesn't matter if it takes Creo, 10 minutes or 20 minutes or 2 hours to regenerate the model all 5, 10, 15, 20 times you ask it to. It'll just keep on doing that iteratively until it generates the full graph for you, right? And so then it's a time-saving feature where you can be more efficient with your time and, perform other high-value tasks while Creo is doing the heavy lifting and changing dimensions behind the scenes, right? Which again saves you, it's incredibly, user-friendly, because that would be, hours that you would have spent manually changing dimensions, right? Where Creo now is doing all of that for you automatically. So it makes Creo much more easy to use, right? So when we talk about design studies, so this would be, an optional step that you could also take, in behavioral modeling, where, on top of creating, some, sensitivity studies to see what the relationship is between your negotiable design variables and your design objectives, you could also do a feasibility study, for example, which is a case where you tell Creo what your negotiable design variables are, right? In this case, you have both of those dimensions for this fuel tank, right? And you tell it what the lower and upper bounds are that it can change it between, right? So for example, Creo can change these dimensions, in this case here, between about 140 to 170, right? And so you tell it what the upper and lower bounds are that it should be within, and then you can also specify for it, some design constraints as well. And this could be a design target where you could say, hey, Creo, I want you to have, the overall volume be equal to, 10 gallons or 15 gallons, or it could be some other sort of relationship, either greater than or less than or equal to, right? So, I want the minimum volume in the tank to be, 15 gallons or so, right? And so you can specify that parameter for Creo to measure, right, automatically. And so that would be a feasibility study, right? And then when you hit OK, Creo will then just automatically keep on going until it finds the optimal solution there that meets, that particular volume constraint that you've set. And then the other case would be an optimization study where, an optimization study is basically a feasibility study, everything we just talked about. But in addition to that, you're also adding in there an analysis goal for Creo as well. So the goal is going to be either to minimize or maximize a certain dimension. So, your goal in this case could be to minimize, for example, the overall mass of the fuel tank, right? So, in addition to meeting, the size or the volume requirements, you want this thing to be as light as possible, because the lighter the fuel tank is, the less weight the car has to carry, and that then plays an impact on, miles per gallon requirements or MPG requirements, and the overall MPG value that the car has, right, and makes it more fuel efficient. And so in that case, you could specify for Creo, hey, while you're changing these dimensions, while you're trying to hit this target for me of the overall volume, also minimize the mass as well, right? Don't give me something huge and clunky, right, in the process. And again, in this example, it's mass. In your example, it could be a ton of other factors. It could be cost. It could be stress. It could be displacement. It could be any other criteria that you define for it in the analysis settings as well. So at this point, we're going to pause here, and we'll switch over. I'll switch my screens real quick, and we'll do a quick demonstration of the software. Yep. Okay. So, all right. So we're currently in Creo. This is Creo 4 right now, and we'll go ahead and play with this and start to show you some of the features in here, right? And so this particular model I have is one of the subcomponents of a much bigger. I think it's a robot assembly, and this is supposed to be one of the gripper arms of that robot assembly, and so this is going to be a mechanized. This is one component in a mechanized, assembly system where we're concerned about weight requirements, right? Because the lighter the component is, right, the less work the motors on that robot have to do to move this component around. And we've also done some prior analyses that also specify the optimal center of gravity that we want to have for this component right here, right? And that optimal center of gravity then means, there's less of a moment arm for the motors to move this arm through, and the motors are doing less work, and we're optimized in terms of, the kind of motion we want to get from this arm, right? And so there's been some prior analyses that have been run, and we've already come up with some, specified or some targeted center of gravity calculations that we want to hit, in this case with Creo, right? And in addition to the center of gravity calculations, we also want to make this as light as possible, right? So again, the lighter this arm is, the less work the motor has to do in order to to move the component, right? So in this case, we'll go ahead and start off here. We will we'll go ahead and in this case, we'll say, for example, we'll start off with this this feature right here, and this is the feature that we're going to create a vacuum within and start to optimize. And we're going to do this using one of Creo's newer features that's not historically been in Creo. I think this was added, I want to say sometime in Creo 4, I believe. And this is going to be the Lattice feature. Right? But before we do that with the Lattice feature, I'll show you a couple things really quickly here. First off, we'll go take a look at the model parameters. And we're going to be using a couple of these parameters in the Lattice feature. So one is going to be this distance and the section size. We're going to use both of these in the Lattice feature for later on. And then the other thing I'll do really quick is we'll do a mass calculation just to sort of see what's going on here. Actually, ideally you'd want to take the mass before you've changed it and hollowed it out. And so I should think that was about 0.02 initially. And now we will do a mass analysis, and the mass comes out to about 0.3 pounds, right, with the original model. And so now we're going to go through our lightweighting exercise here using behavioral modeling combined with the Lattice feature inside of Creo 4. And so we'll make that a vacuum, and now we'll then go ahead and start to specify our Lattice feature, right? All right, so once we select on the references in this case to define the space where the lattice is going to be, which is this empty space over here, we can now start to define our lattice, cell size or geometry size, and then Creo can then fill in the entire space with those cells, right? And so in this example here, we could say, for example, you want to specify just a regular 3D lattice, as it looks currently. You can also then specify, how Creo should resize or scale the cells based on the current size that's being shown over here, right? Or we can also modify the size of this current cell that's currently being shown, and we can do that, and we have the flexibility to change all of the dimensions that for this particular object. So say, for example, in this case here, we want this to be a square, right, with those those dimensions, and I wanted to scale it down to half of its size, and now we could preview what the feature is going to look like. Yep, and now Creo fills that in with lattice material, and you could sort of see what that looks like all the way through on the inside. Right? Now for this model here, we can also, you have a wide variety of lattice options that are available to you, right? So you could also do it from a 3D lattice to, for example, in this case, a 2.5D lattice, where you can specify a different shape for the cell size. So we can say we want it to be a hex shape, right? And then we'll make a couple changes here to the, actually no, we'll leave, we'll leave the wall thickness and make a couple changes here to the width and the length. Yep, and we'll specify that for again the overall width and length sizes over here for the cell that we want to put in here, and we can again do a quick preview of that to see what it looks like, right? So this could be another way we could structure our lightweighting feature in there. Or we could also come back in here and say, hey, let's add drain holes into this, right? And we could go ahead and preview that again and see what the and see what the model looks like, right? And in this case here, adding the drain holes could be, for example, if this model was 3D printed on a powder bed Fusion machine. you'd want to have some drain holes in order to allow the unfused powder to escape, and as you're in your final post-processing steps, right? And this could be a way to accommodate for that, right? All right, so we'll go back and we'll tweak these values again back to some specific dimensions that we want to use, and we want to optimize. We want to optimize in this case for our lattice features. So we'll okay. Okay. And the other thing we'll do in this case is we'll go ahead and create a variable density lattice, and this is where we're going to use those we'll use those parameters that we showed earlier. In this case, we'll add those parameters in here as a reference for these parameters over here. So now, Creo is going to take those, it's going to go find those parameters, grab the value, and use them as inputs in this case here, right? And we'll go ahead and select our reference. In this case, it's going to be for our variable density lattice, the area that Creo should specify for it. And now we'll go ahead and preview what the result is going to look like. All right, it looks like Creo's having a little trouble initially here, so we'll do this and we'll preview this again really quickly. All right, and in this case, this would be how the lattice structure would look like, right? And so I'll come in here and we'll add a few more tweaks in here really quickly. Yep. Okay. And we'll say this is what we want it to look like, and so we'll accept this here and we'll hit OK. And now Creo is going to think and go ahead and add in. Actually, nope. Let's remove that. Okay. Yep. Okay. So there we go. So this is what the current lattice structure looks like, right? With all those beams and the balls at the end of those beams here to serve as an articulation point for each of those beam members, right? And again, the goal of this is to show the behavioral modeling features of this. So we'll go ahead and start to do that. So we'll come over here back into our mass properties analysis, and we'll do a very quick mass properties analysis here again. And we'll notice here that we're down by from 0.3 pounds to about 0.224 pounds, right? Which is about almost a 30% weight savings, right? Which again, in context, 30%, that's a very good amount of weight savings for a model. And so we've dropped down the weight, but now we want to optimize the position of the center of gravity of this model, right? And so in order to do that, what we're going to do, and this is going to be where we're creating in behavioral modeling, this is where we're going to create our analysis feature. So now we're telling Creo to create a feature for our mass properties, and we are going to go specify what it should create for that feature in this case, and we're going to ask it to create parameters for the X, Y, and Z center of gravities, right? So it's going to take the dimension value for the X center of gravity, the X value of that, and it's going to report that in a parameter, and likewise with the Y and the Z as well, right? And then we'll hit OK, and it'll create that as a feature there in our model tree, right? All right. And so next, we're going to then go ahead and take a look at doing a feasibility or an optimization study. In this case, we'll go feasibility, and we'll add in here those specific X, Y, and Z values. And so in this case, we're going to say we want our X center of gravity, and say we want that to be a specific target, and it could be, equal to or greater than or less than. In this case, we'll just go, we want to set that equal to a certain value, and we're just going to go ahead and type in values that in this case we've already calculated from some prior analysis, right? It could be some other prior analysis, and we'll just go ahead and put those in there. So we'll put in the one for the X, and then the Y, and then the Z as well. Yep, and that's going to be that. And next, we're going to add in here some negotiable dimensions, right? So these are going to be the dimensions that Creo can change and tweak. And so we're going to go ahead and specify in here. For example, we'll say we'll take this dimension here for that particular feature. And let's see, we'll go ahead and grab this one dimension for the position of that fill plane, and then finally we'll go ahead and grab this third dimension down here, right? And now we'll go ahead and specify what the lower and upper bounds are going to be that Creo can change those dimensions between. All right, so we're done adding features and dimensions and parameters, and now we're just going to go ahead and have Creo run the calculation, and then try and find us an optimal design solution that fits within those parameters, right? And you'll notice while it's running, you'll notice there's a mass properties calculation, and then it says mass properties calculation here is 100% complete, and it'll keep on repeating that a couple times. And basically what Creo is doing at this point is it's going to change the model, right? It's performing the mass properties calculation just as we defined it in the model tree. It's checking the X, Y, and Z center of gravities to see if they match what we've already set. And if they don't match, it's going to go back again, change the model based on our design variable limits, and then perform the same action again, right? And so now this is a case where Creo is doing the heavy lifting for you, and it's trying to tweak your model to fit your design variables or your design targets. That in this example model here, Creo went ahead and ran the analysis, and we'll notice that I'll just quickly hit compute again really quickly. It's going to compute the same values, but it computes the values. It finds a feasible solution where our center of gravity meets these particular values right here. And at the end of it all, when Creo is done, it changes the design variables. It changes them from the original values that we had to new values, right? Based on what what's it called? Based on the inputs that we had in here for the design constraints, right? And normally, whenever we would hit close, it doesn't show that in this case because we already had it done. But it would ask you to regenerate the model to the new settings. And so once you do that, the new parameters would automatically be applied, and now we have our model that's optimized to our specific center of gravity requirements or targets, and we are already, again, 30% lighter than the original design, right? And so this shows a way that you can use behavioral modeling to embed your design targets or your design requirements into your Creo model, and have Creo design your model and tweak the dimensions to fit that particular design target that you have, right? And then finally, the other thing that I would show really quickly here, even though we didn't show that in this example here, is that with behavioral modeling, it's much more than just doing mass calculations as well, right? So within Creo, there are many other features that you can do as behavioral modeling features, right? So you have, for example, you can do measurement analysis features where you can measure a certain dimension or a length or the surface or a volume, and you could have those as analysis features that you can specify as for Creo to set as design targets. You could also do a whole bunch of others as well. So for example, you could specify an Excel analysis feature, right? That's where Creo goes to a certain Excel file that you predefine or specify, and puts in some input values in there. Excel runs some calculations and spits out some output results, and then Creo reads in those output results, right? And so then that Excel file could be, for example, some company-specific document that charts, maybe, for example, it could be the cost. It could be a cost specification document that specifies, how much a certain model is going to cost based on certain parameters, right? You could also have it run, a MathCAD analysis feature where it's go into MathCAD Prime, or MathCAD 15 or earlier, any of the legacy MathCADs, and querying them for information, getting a result out of it, and then using that result in here as your design objective, right? Or it could be a Creo relation, right, where you type into Creo relations any sort of calculation you want to run and to use that as your objective function. Or it could also be a Creo simulate analysis as well, where behavioral modeling is going to Creo simulate. It's getting, for example, it could be a maximum displacement of an analysis, and then trying to optimize that displacement to a specific value, or maximize or minimize that, right? And so there are many different analyses types that you can modify and tweak and change and set as design targets within behavioral modeling. And yeah, that's just a small sampling of them here. But again, that just goes to show you, the breadth of things you can do with behavioral modeling and embedding, design requirements into your Creo models. Right? So at this point, we'll switch over and really we'll ask, a couple, one simple question again, and that's really, what's the point? What's the point of what I just showed you? What's the point of, behavioral modeling and the fact that you can do all these things? And really, it's the fact that, number one, you can increase efficiency, right? You can set Creo to manually run these tasks while you are doing other high-value engineering activities. You can also increase the efficiency and really the quality of your design model, because now you've built into it a high-quality design objective and the parameters that accurately meet that. You can reduce the time to market because you're spending less time iteratively changing your model and seeing what the result is going to be. Creo gets you the perfect answer as quickly as possible, and then you can move on to other phases of your design process, right? And then finally, you can also reduce cost as well, because you can build in cost as a feature for behavioral modeling to optimize as well, and you can also then have it minimize cost. Say, for example, you can consider weight in an Excel calculation as a cost-saving benefit, and then Creo can minimize the cost of a part, and you're also spending less time, which is again related to cost with designing the model, because behavioral modeling is doing a lot of that hard work for you on the front end. And so again, that just goes to some of the benefits that you can reap from using behavioral modeling, embedding those design requirements into your models. Yep. So at this point, we'll pause here for any questions. And now we'll take a look at some of the questions in our in the questions box here and see if there are any questions that have been submitted so far. All right. All right. So one of the questions that that pops up is is there a way to if the model changes, is there a way to sort of, I guess you'd say, rerun the analysis feature again, if there's some engineering change to the model, right? And the answer for that is always a yes, right? So you can always, say, for example, the customer asks for a design change and we make a change to this model, we could still go back to that, behavioral modeling feature, and we could rerun the analysis on there. And then it'll rerun it based on the current new model. It'll adjust the dimensions if it needs to, and it'll get you another result that's feasible, right? If that's within the design space of the model. And the other thing as well is if you can also save the behavioral modeling feature. In this case, if I go as an optimization feature, you can also save this as a feature. And usually that would be after you compute the analysis. And when you save that as a feature, it'll appear in your model tree, right? And then the beauty of that is, a month or 3 months from now, whenever there's an engineering change and someone comes in and takes a certain dimension and changes it from 1 to 5, the model changes, and as part of the regeneration process, Creo will then regenerate and recalculate that behavioral modeling feature already. And so then that way, you're sort of building in the optimization into your model as well. Yeah. Cool. So I think that's all we have by way of questions at this point. We'll go ahead and end the webinar right now. Thanks so much for tuning in to today's edition of Boundaries Webinar Wednesdays. If you have any questions about behavioral modeling, how to use it or things like that, technical questions, you can there's my contact information is up on the screen. And if you have any I guess sales related questions when it comes to how much is this particular offering or things like that, you can email our sales team on there as well. And again, thanks so much for being a part of this webinar, and we look forward to seeing you on a future edition of Boundaries Webinar Wednesdays. Thanks a lot. Goodbye.